Elon Musk is a man on a mission. He wants to see humans living on Mars as soon as possible. This burning desire of his needs a brand new spacecraft, which he is rapidly building. However, Musk wants to hasten the development process, which is why his company SpaceX is using a very innovative method to construct the parts for its rockets. That is 3D printing. How is SpaceX printing rocket parts, and is 3D printing safe to use in rockets? Join us as we dive into SpaceX's futuristic 3D printing of rockets. 3D printing is one of the cool tech people hear about and see for the first time and go, wow. It is never not amazing to watch a piece or component grow from a speck into its full size. Then comes the barrage of questions. How does it work? Can it print using any material? Can it print a car? What about a house? However, not many people will ask if 3D printing can work for rockets, except if they are Elon Musk, who takes dares for a living. The billionaire tech entrepreneur is always willing to take bets where others will be conservative. But first, how does 3D printing work? This question is important as it will help us see how 3D printing fits into Musk's plans. 3D printing is also known as additive manufacturing, and the name makes sense as the concept involves adding more materials until you get the shape and size that you want. The process starts with a digital file, and you end up with a solid three-dimensional object. You get to this final destination by laying down successive layers of material until the object is created. Each of these layers can be considered as a thinly sliced cross-section of the object. This process is different from subtractive manufacturing, which means you keep removing material from a solid object until you get your desired shape and size, as it happens in milling workshops. One major advantage with 3D printing is that you can make complex shapes easier and magnitudes faster than with traditional manufacturing processes. 3D printing is now routinely used in many industries, as it has passed the stage where it was only useful for making prototypes and can now make full-blown products. They are used in fields like healthcare to consumer products. They also make good tools for teaching design. Acumen Research and Consulting forecast that the global 3D printing market will reach $42 billion by 2026. SpaceX began dabbling in 3D printing in 2014. Because of its ability to cut down fabrication processes that would have taken months to do into days, 3D printing fits nicely into Musk's plan. He's racing against time to get his Mars colonization project off the ground. Doing so would require making many units of its latest rocket, the Starship. Manufacturing the Starship is no mean feat, given the expectations. It is going to be the tallest rocket ever built, towering 120 meters when assembled. It will also be the most powerful, as Musk needs to transport tons of cargo to create all the support systems that his Mars volunteers will need when they start arriving. It will carry more than 100 metric tons to Earth orbit. All these with the additional requirement that the stages are to be fully reusable, which adds another layer of complexity. Musk's plan is to get SpaceX to the level where it can make a complete Starship in 3 days, which will require immense speed. There is another reason Musk wants to speed up the development of his rocket. NASA will soon resume flights to the moon, which has stopped receiving human visitors since 1972. SpaceX is going to play a huge part as NASA astronauts will descend to the moon's surface using the Starship, for which NASA is paying SpaceX almost $3 billion. Time is ticking, and Musk has to hurry as the whole nation is waiting on his Starship rocket. This deadline is even closer than his own Martian dreams. For these reasons, SpaceX is building and testing Starship prototypes at breakneck speeds at its Texas facility. The numerous parts have to be fabricated as fast as possible to keep up with the scheduled tests before the Starship is deemed fit to work. This is where 3D printing comes in, as it is a faster method of fabricating parts. It also has the advantage of reducing manufacturing costs. Here is how the cost works. This might surprise you, but the cost of a rocket is not determined by its raw materials, as they are pretty cheap. Instead, the cost is driven by the human labor needed to transform these materials into usable components and verify that they will work as intended. Rockets notoriously have many parts. For example, the space shuttle system has 2.5 million moving parts. Every part must be manufactured, tested, installed, and tested again, all the while keeping documentation. To reduce the costs, you have two options. You can reduce the total number of parts in a rocket, so less labor is needed, or you can change the manufacturing process to cut the need for human minds and hands. SpaceX is using a combination of these methods, as 3D printing lets you reduce the number of parts that you have to make and keep track of. Without 3D printing, SpaceX will have to create these components and then join them together, but 3D printing allows the company to combine some parts into a single piece. Any method that cuts costs and saves time, you can be sure Musk will try it. This is exactly what Musk is doing following with his other company, Tesla, where huge gigapresses make car chassis in 2 or 3 pieces, a process that eliminates much welding, riveting, and sealing. There is even a rumor that Tesla will make the whole chassis of a small car in a single piece using a more powerful gigapress in China. SpaceX has been 3D printing some parts of its rockets for some time now, and they have worked with no issues. The company has used 3D printing in the Super Draco thruster engine for the Dragon spacecraft and in one of the Falcon 9 rocket engines. The Super Draco thruster engine is what the Dragon spacecraft uses to maneuver in orbit and during re-entry. The Dragon version 2 spacecraft also uses Super Dracos in the crewed version, where they power the launch escape system that is integrated into the spacecraft. SpaceX 3D printed the Super Draco engine chamber using Inconel, a high-performance super alloy using direct metal laser sintering. This method uses a computer-controlled high-power laser beam to melt and fuse layers of metallic powder together. The next layer is then added on top, and the process is repeated, thus sintering each layer to the previous one. All of this 3D printing was done in-house by SpaceX. The engine chamber SpaceX 3D printed could withstand the powerful thrust created when fired. This 3D printing allowed SpaceX to move fast from the first concept to the first hot-fire test in less than 3 months. SpaceX also used 3D printed parts in its Falcon 9 rocket, which flew the Tycom 6 mission. One of the rocket's Merlin 1D engines contained a 3D printed main oxidizer valve body. The valve opened as expected with high-pressure liquid oxygen and withstood high vibration and cryogenic temperatures. It has better strength, fracture resistance, and ductility than if it had been made through traditional casting. But more importantly, it was a lot faster to make because it only took 2 days instead of several months. SpaceX has been using the 3D printed valve in its Falcon 9 flights since then. While unveiling the first fully 3D printed rocket engine, Musk spoke enthusiastically of the method of fabricating, saying, "Through 3D printing, robust and high-performing engine parts can be created at a fraction of the cost and time of traditional manufacturing methods." SpaceX is pushing the boundaries of what additive manufacturing can do in the 21st century, ultimately making our vehicles more efficient, reliable, and robust than ever before. Thanks to the 3D printed part, the Merlin and Super Draco parts played a crucial role in the evolution of SpaceX to where it is today. The Falcon 9 rockets have launched NASA astronauts on their way to the International Space Station. The rocket has even become the most flown currently operational rocket in the US. However, 3D printing is more useful to SpaceX than just rocketry. The company has employed 3D printing in the design of the spacesuits astronauts wear aboard its spacecraft. They are sleek-looking, functional, highly efficient, and easier to wear and remove. They're also custom-made for each astronaut to provide maximum protection from potential depressurization. The helmets were custom-made using 3D printing, with integrated valves, visor retraction and locking mechanism, and microphones included. The company that supplies the 3D printers SpaceX uses says the space company has been using 3D printing for the parts of the Starship that has been difficult to make using traditional methods. The company Velo 3D claims SpaceX was having significant trouble with a part and then decided to switch to 3D printing to save time. Other companies have been inspired by SpaceX to employ 3D printing in making their rockets. For example, Relativity Space hopes to make a fully reusable rocket completely from 3D printing. Let's hear what you think of SpaceX's 3D printing in the comments section below.